one of my former students asked me a series question in calculus, and I was really happy because I was able to solve it. I haven't done calculus for so long. So let's see what is the question about. So the question was, find the radius of convergence of the series n is equal to 3 to infinity. I have x to the 2n over log n, everything raised to the n on the bottom. So whenever you are trying to find a radius convergence, we are going to use the ratio test. So use ratio test, which says I want to calculate the limit when n goes to infinity, an plus 1 over an, and with the absolute value around it. And an is exactly this. So let me make a note. An is equal to x to the 2n over ln n raised to the nth power on the bottom. So check. I want to get the limit when n goes to infinity, an plus 1 over an. So I have the limit when n goes to infinity. An plus 1, let's see, I have x to the 2 n plus 1 over ln n plus 1 raised to the n plus 1 power, right? And then on the bottom is just exactly the same, x to the 2n over ln n raised to the nth power. And I guess the absolute value is not needed because everything inside was positive anyways. So this is the limit when n goes to infinity. And I have on the top right here, I have x to the 2n plus 2 over ln n plus 1 raised to the n plus 1 power. And let's just simplify this complex fraction. So when you have top divided by the bottom, you write on the top and then you can multiply and flip the bottom. So I will take this ln n raised to the n power over x to the 2n on the bottom. And right here, the x to the 2n actually cancel out, so I just have the limit when n goes to infinity. X to the second power right here, times this ln n raised to the nth power over ln n plus 1 raised to the n plus 1 power. So what does the n power mean and the n plus 1 power mean? That means we'll just take the n ln n inside multiply by n times. Likewise, right here, I will take ln n plus 1 multiply itself n plus 1 times. So we will get this is the same as the limit when n goes to infinity. X squared times ln n times ln n times ln n. Let me make a note. This is n of the ln n over, on the bottom I have ln n plus 1 times ln n plus 1 times ln n plus 1 ln n plus 1. And on the bottom right here, I have a total of n plus 1 ln n plus 1, right? N plus 1 of the ln n plus 1. And right here, let's take a look. ln n over ln n plus 1. Each of this actually goes to 1 when n goes to infinity. So let me make a note on the side. Notice that ln n over ln n plus 1, this goes to 1 as n goes to infinity. As you can see, right, ln n over ln n plus 1, they're just off by the 1. So it actually doesn't matter, the plus 1 doesn't really affect anything, so they are pretty much the same when n gets large. So that means this factor goes to 0 and this factor goes to 0. Likewise, all this factor goes to 0 except for one of the ln n on the denominator. So all this turns out to be, this is the this is the limit when n goes to infinity, x squared over ln n plus 1. And notice that the x doesn't really matter, it's just like a number. Okay, and then right here we have n goes to infinity. Then n is only on the denominator. So when n goes to infinity, we have n on the denominator. So we'll have like something over infinity on the denominator. So it's just like 0. When the limit is always equal to 0, that means this series always converge. This series always converge. Always converges. So in another word, I can plug in any number for x, and then this series will always converge. So I can give you some examples. Let's say I have this series 1972 raised to the 2n power over ln n to the n power. This guy will converge. Or I can have another guy. Let's say I have 1/2 or 1.45 raised to the 2n over ln n raised to the n power. This guy also converges. So that's what it means when you have a series that always converge. You can plug in any number for x, and then this guy will always turn out to be a finite sum.